The first equation that we're going to be looking at is for the constant rate period. So let's say the length of the time required to dry a material for initial moisture content. So we can label the initial moisture content as x1 to the final moisture content can be divided into two. One is for the constant rate period and the other one is for the falling rate period. Now when we are talking about the constant rate period, the drying time can be calculated if, let's say, x1 and x2 are greater than xc. So if we look at back our graph here, so our x1 and x2 must be in between B and C line here. So we can say that maybe our x1 is here, our x2 is here. So both of this value must be greater than xc. Then only it falls under constant rate drying. If our final value is below xc, meaning that it's a combination of constant rate drying and falling rate drying. So for that case, we'll have to combine both of the equation. But for now, we are just looking when x1 and x2 are greater than xc. So we can actually find the time for drying by two methods. Method number one is that we just straight away use the drying curve. Right? We can just straight away use the rate of drying curve. The second one is that we can use the rate of drying curve for constant period. So meaning that we can just use this equation. So we have also defined that R is our constant, the constant rate period. M is the mass of bone dry solid. A is the area of drying. Dx is the difference in the moisture content, where x is your moisture content and dt is your difference in time. So after we rearrange this equation, we do integration to this equation for between x1 and x2. So we will get this equation. T here is our time for drying. Time for drying in constant rate period drying. So T is equal to ms A over RC in bracket x1 minus x2. So remember why x1 minus x2, because we have this negative sign. So this negative sign indicates that we want our rate to be positive, and because we want our rate to be positive, and we also want our time to be positive, because we cannot have negative time. You cannot have I'm drying a material in negative 20 seconds. So it doesn't make sense for us. So that's why by having this negative sign, we can actually manipulate our difference in moisture content to become x1 minus x2, meaning that our delta x here is always greater than 0. It's a positive value.